Good morning, everyone. Today I'm gonna talk about NASA DART missions, which stands for Double Asteroid Redirection Test. That was an important mission because it was the first real test of asteroid diffraction. In simple words, NASA wanted to see if a spacecraft could crash into an asteroid and change its motion. This mission is connected to planetary defense, which means protecting Earth from possible asteroid threats in the future. DART was not launched because an asteroid was going to hit Earth. It was a test mission designed to help scientists learn what could be done if a dangerous asteroid were discovered one day. Today I will explain why DART was important, what asteroid system it targeted, how the impact worked, what the results were, and why this mission matters for the future of astronomy and planetary defense. That was important because asteroids can be dangerous if they cross Earth's path. Most asteroids are not a threat, but scientists still track them because some objects in space can come close to Earth. If a large asteroid were ever discovered on a collision course with Earth, scientists will need a way to respond before it becomes too late. That is why NASA studies ways to protect Earth. DART tested one possible solution, changing, changing the motion of an asteroid by hitting it with a spacecraft. The goal was not to destroy the asteroid like in movies. The goal was to slightly change its path. Even a small change can make a big difference over time if it happens early enough. That was created because scientists wanted to test asteroid defense before a real threat happens. This is important because it is better to practice this technology in advance instead of waiting for an emergency. Planetary defense is the larger idea behind the DART mission. It includes finding and tracking near-Earth objects, studying their orbits, and preparing possible ways to protect Earth. Near-Earth objects are asteroids or comets whose path brings them close to Earth's orbit. Scientists use telescopes and space missions to observe these objects and predict where they will go in the future. This matters because if an asteroid is found early, there might be enough time to change its path. One important idea is that a small change in asteroid motion can make a big difference later. For example, if an asteroid is pushed slightly just before it reaches Earth, that small push could cause it to miss the Earth completely. Dart tested whether this kind of change is possible using a real asteroid system. Dart tested a method called kinetic impact. Kinetic impact means using motion and collision to change the path of an object. In this case, NASA sent a spacecraft to intentionally crash into an asteroid. This spacecraft did not carry explosives, it did not try to break the asteroid apart. Instead, it used its speed and mass to transfer momentum to the asteroid. When the spacecraft hit the asteroid, it pushed it slightly and changed its motion. The goal was to see if this method could work in real life. Before that, before that, scientists have theories and simulations, but this mission gave them real data from an actual impact in space. That is why that was such an important step in planetary defense. The target of DART was a binary asteroid system called the Deimos and Dimorphos. A binary asteroid system means there are two objects, one large asteroid and one smaller orbiting around it. The Deimos is the larger asteroid and Dimorphos is the smallest moonlet. Dimorphos orbits the Deimos similar to how the moon orbits Earth, but on a much smaller scale. NASA chose this system because it was easier to measure the change. DART was not trying to move Dimorphos toward or away from Earth. Instead, scientists measured how the impact changed the time it took Dimorphos to orbit the Deimos. This makes the mission safe and easier to study. This is also important because Dimorphos was not a threat to Earth. NASA used it as a test target, which allowed scientists to practice asteroid deflection without creating danger. The spacecraft DART launched on November 24 of the year 2021. The spacecraft had to travel to space and eventually guide itself toward the morph. Sorry. This was a difficult task because the Morphos was small compared to the distance the spacecraft traveled. One important part of the spacecraft was its camera system. The camera helped DART see the asteroid system and navigate toward the correct target. As it got closer, DART had to identify the Morphos and steer itself into it. This shows that the mission was not only about crashing into an asteroid, it was also about navigation, engineering, and precision. The spacecraft had to hit a small moving target in space at very high speed. That makes the success of the mission even more impressive. How the impact worked. The impact worked by transferring momentum. Momentum depends on an object's mass and speed. Since DART was moving very fast, it could transfer momentum to Dimorphos when it hit. When DART crashed into Dimorphos, it pushed the asteroid moonlet slightly. But was but there was another important effect. The impact also caused debris to fly off the asteroid. This debris created an extra push, almost like a recoil effect. That means the asteroid was not only pushed by the spacecraft itself, but also by the material that was blasted away after the impact. This helps scientists learn more about how asteroids respond to impacts. Not at all asteroids are made the same way. Some might be solid rock, while others might be loose spirals or rubble. That gave scientists real information on how an asteroid like Dimorphos reacts when it hits. The impact happened on September 26th of the year 2022. On that day, Dove successfully hit Dimorphos. The spacecraft was traveling at about 6.6 kilometers per second, which is extremely fast. This was the most important moment of the mission. Scientists and people around the world watched as Dove got closer and closer to the asteroid. The image from the spacecraft showed Dimorphos becoming larger right before impact. Then the signal stopped because the spacecraft had crashed into target. Even though the spacecraft was destroyed, that was exactly what NASA wanted. The mission was designed to end with the impact. After that, scientists used a telescope and observation to measure what changed in the Dimorphos orbits. Sorry. The results show that DARSA was successful. Before the impact, Dimorphos took 11 hours and 55 minutes to orbit the Deimos. After the impact, the orbit changed to 11 hours and 23 minutes. That means that the orbit changed by about 32 minutes. This was a major result because it proved that the spacecraft actually changed the asteroid's motion. NASA only needed to show a small measurable change, but the actual change was larger than the minimum requirement. This is the most important evidence from the mission. It shows that kinetic impact is not just an idea, it can work in real space conditions. Scientists can now use the data to better understand how much force is needed to change an asteroid's path. That matters because it proves humans can change the motion of an asteroid. This is a big achievement in astronomy and space science. The mission is important for future asteroid defense because it gives scientists a tested method that could possibly be used if a dangerous asteroid is discovered early enough. Again, that does not mean Earth is completely safe from all asteroid threats, but it does show that science and technology can help us prepare. Another reason it matters is that it connects astronomy to real life. Astronomy is not only about studying distant stars and planets, it can also protect our own planet. That is a good example of how space research can have practical importance to Earth. In conclusion, that was a successful mission and a major step in planetary defense. NASA launched the mission to test whether a spacecraft could change an asteroid motion, and the result showed that it could. The mission targeted Dimorphos, the smallest moonlet orbiting the Deimos. Vacation into Dimorphos Dark changed its orbit by 32 minutes. This proved that kinetic impact can be an effective way to alter the motion of an asteroid. Future research will continue with missions like EVA's mission, sorry, which will study the impact site in more detail. EVA will help scientists understand the crater, the shape of Dimorphos, and the long-term effects of that impact. To me, the most interesting part of this mission is that it was not just about exploring space. It was about learning how to protect Earth. DART, DART showed that if humans discover a threat early enough, we might have the technology to do something about it. These are the resources I used for my presentation. Most of my information came from the NASA because DART was a NASA mission. I also included information from a European Space Agency because of the Hera mission, which will continue studying the Didymos and the Morphium system. Thank you for listening to my presentation.